Hello viewers, welcome to All-in-One Content YouTube channel. I'm Eswar. On this channel you'll get everything in one place.
In this video, we'll discuss three different sorting techniques. They are bubble sort, selection sort, insertion sort.
Begin. 1. Bubble sort. Compares each pair of adjacent elements in the list. Swaps them if they are in the wrong order. After each pass, the largest unsorted element moves to its correct position. Repeats the process until the entire list is sorted. Let's understand how bubble sort works. A simple and beginner-friendly sorting algorithm. It may not be the most efficient, but it's perfect for learning how sorting happens step by step. We begin by looking at a list of numbers and comparing two adjacent elements, one number and the one right next to it. If the number on the left is greater than the one on the right, we swap them. This way, the larger number moves one step to the right, getting closer to where it belongs. We then move to the next pair and do the same, compare and swap if needed. This continues across the list, going from the beginning to the end. By the end of the first pass, the largest number has reached the last position, just like a bubble rising to the surface, which is where the algorithm gets its name. Now that the biggest number is in place, we go back to the start and repeat the process. But this time, we don't need to touch the last number. It's already sorted. In the next pass, the second largest number moves to its correct position. With each pass, the unsorted section gets smaller, and the sorted part grows from the end. This process continues, comparing, swapping, and shrinking the unsorted portion, until eventually there are no more swaps needed. At that point, the list is fully sorted. Bubble sort is easy to implement, easy to visualize, and a great way to understand how basic sorting works. Its time complexity is O(n) squared, which means it can be slow when dealing with many elements. This is because it often needs to make many passes through the list, even for small changes. So, while it's great for learning, it's not used much in performance-critical applications. This is a simple-to-understand but slow algorithm because it takes multiple iterations to sort the entire list. That's all for the bubble sort technique. Now let's move on and learn about selection sort. 2. Selection sort. Finds the smallest element from the unsorted part of the list. Swaps it with the first unsorted element. Moves the boundary of the sorted part one step forward. Repeats the process until the entire list is sorted. Let's now look at selection sort, a simple and beginner-friendly sorting algorithm. The main idea is to divide the list into two parts: a sorted section at the beginning and an unsorted section that contains the rest of the elements. We start by scanning the unsorted part of the list to find the smallest element. Once we find it, we swap it with the first unsorted element, placing it in its correct position in the sorted section. Then we move to the next position and do the same. Look through the remaining unsorted elements, select the next smallest, and place it in the next position. With each pass, the sorted part grows from the front, and the unsorted part becomes smaller. This continues until all elements have been placed in order. Selection sort is easy to understand and has the advantage of doing fewer swaps than bubble sort because it only swaps once per pass. However, it still goes through the list repeatedly, so the time complexity is O(n) squared, which means it becomes slow as the number of elements increases. But overall, it's a great way to learn sorting, especially for beginners, with a clear step. 3. Insertion sort. Starts with the second element, treating the first as a sorted part. Compares the current element with elements in the sorted part. Shifts larger elements one position to the right. Inserts the current element into its correct position. Repeats until all elements are sorted. Let's understand how insertion sort works. It builds the sorted list one element at a time. We start with the second element and compare it to the one before it. If it's smaller, we shift the larger element to the right and insert the current one in the correct position. This process continues for each element. Take the next one, compare it with elements to its left, and keep shifting until it fits in the right spot. By the end, all elements are in order, just like sorting cards in your hand. Insertion sort is easy to implement and works well for small or nearly sorted data. Its time complexity is O(n)(2 in the worst case. And that's how insertion sort works. Simple, efficient for small
Don't forget to subscribe and click the bell icon for more content.